Alright, g'day everyone. So we're back at it again, and this is the day where I finally actually test the amplifier. So I need a variable signal generator, and the only one I've got, the HackRF. Tony sent me this, so all good. It goes through the QRPP amplifier, the one that does not have receive transmit switching, so it just stays PTT all the time. That goes through a 40 meter filter, that goes to the amplifier, and from the output of the amplifier, it goes straight to the dummy load into the spec an. So this is going to be artificially worse than what you'd put out on the air. I do need to turn this down so you can actually see it. Yeah, probably best to lock the exposure down there like that. If I could lock that would be nice. There we go. So you can actually probably read that now. Yeah, that'll do. Rightio. Oh yeah, I've got the PTT line here. So all I have to do is push that in. And the amplifier is engaged. Now, do need to hook up the QRPP amplifier, so we'll do that now. And you're going to start to see carrier leak from the HackRF. Actually, no, you won't, because the amplifier is not engaged. You'll see nothing, because it's all terminated right here. Now, if I engage the amplifier, that's what the HackRF puts out. This is a VFO at 7 megahertz. See if I can refocus that. Yeah, VFO at 7 megahertz, but I've got my carrier on 7132, which is the frequency I talk on all the time. Now, this is going to be uneventful, well, probably. So what we'll do is, this is my little control circuit. I have a little percentage on the power, and I have a button to trigger the PTT, just so I can turn it on and off quickly. So, unfortunately with the NVNC, I have to tap and then hold and drag sideways to make this work, but let's see what happens at 13% power. And it goes up to 36 dBm, which is 2 watts or so. Oh, so you didn't see the output on the scope there. Hang on, if I could look there, hit the activate, and you'll see on the output of the scope, that's at 25 volts of division 2, so yeah, it doesn't look the prettiest. The waveform's not too bad though. So there we go. Alright, I'll increase the power. I'm going to go straight to something reasonable. So here's, let's go to like 25-ish%, not 54 at all. It won't work. Yeah, let's go 20% power. I believe, I don't know, like 50% might be 1 watt, and then I'm just overdriving my QRPP amplifier, but there we go. So 36 dBm at 20% power. Let's go 30% power. What's that, 43? 44 dBm? Yep, 44 dBm. Increase the power a little bit more. Where are we? 38% power. Oh, hang on. 45.4 dBm. Not too bad. A little bit more. So we're at 40% power. And it drops out. Yeah, that's not an explosion. What that is remember, I'm going to go back to normal brightness. I've got this current limit here. That's a 0.1 ohm resistor, and it triggers a transistor. So this trips out at 6 amps. Now, 6 amps is enough to get me, you know, multiple tens of watts, but it's not enough to get me 100 watts at 24 volts. So I need to go adjust my the thing. So I'll just prove that it's still working. So I just maybe turn this down to whatever. Where are we at? 36% power there. It might work. Trigger the amplifier. Come on, amp, turn on. What's wrong with you? There you are. And we activate. Yep, 46 dBm. So that's 40 is 10. So 20 is 43, so 40 would be 46 dBm. So I'm getting about 40 watts out, which is what I had with the old amplifier. But remember, this is current limited right here. I need to change that. Well, actually I need to just solder a resistor in parallel. That'll give me 12 amps in total. And that should get us close to 100 watts. Just to check the MOS, well, so the temperature. Whoa! Oh, never mind about that. You saw a little flash. This has B+ on it. Forgot about that. Yeah, we might want to make sure that everything still works after just doing that. So we'll fire up the bias. Yeah, there we go. Of course it still works. Oh dear, that was scary. That was a short circuit on 24 volts. Anyway, I'll key the activate and it'll be fine. Yep, there we go. Oh, 43 dBm. But I did pull the power back. Anyway, there you go. Oh, hang on, that's still pulled power back. 39. Uh-oh, I only got 43 dBm there. Wonder what happened there. Anyway, we'll work it out, make some more progress. See ya. Catch you later. VK4 Delta Lima. Alright, one more test. So we'll try and get this all in frame. So we're starting at 30% power. $43 dBm. 37% power. 45 dBm. This is with the increased current limit now. 46 dBm. 47 dBm, that's 50 watts. 47.3 dBm, we're getting pretty fucking good. There we go. Let's bump it up more, I guess. I'm pretty sure that this is going to explode, but we're going to find out. 48 dBm, we're getting there. 47.3. 47.8. Okay, it's interesting. Went a little bit higher on the power and then we're starting to drop power. 47.48 dBm almost. Alright, we'll go to 60% drive. 47.8. We might be at the limits of my QRPP amplifier. I thought this was going to give up first. Maybe I'll just put a little bit more into it, like maybe 70%. There, that should be pretty close to a lot of power. A little bit scared of doing this, but we'll see. 48 dBm. So no, we're getting more. Nah, we're kind of tapped out here at 48 dBm. So it's not really that hot. I mean, it's warm. I can't keep my finger on it, but the heatsink's pretty cold. Well, yeah, it's like nice warm bath temperature type of thing. So we're making progress, but I'm pretty sure this is my problem. I'm gonna go test that. What I'll do is I'll put the output of this straight into the well, you know, not straight in, through the attenuator on the Tiny SA, the spec N, and we will see what happens. So I've unplugged the main amplifier. I don't need it. We will hook up spec N to this setup and see what we can top out at, like where we top out at with the percentage scale and that amplifier. All right, be right back. All right, now you're going to be looking at the input of our amplifier. So this is no amplifier, this is just the QRPP amplifier. All right, okay, so I've got a lock focus here, turn down the brightness so you can actually see what I'm doing. And could be focused a little bit better up on the Tiny SA there. Okay, all right, let's give this a go. So what are we at? It's -6 dBm carrier leak from the Hacker F. We'll fire up. Oh, that's 1 watt of drive already. and that's all that this can do. This is at 70%. So I'll go back to like whatever it was, 60%. I think we started to lose the power gain. Yeah, already at 30 dBm. That's 1 watt of drive. Now if I go up to 100%, it's not going to matter. Just massively overdrive the amplifier, 30 dBm. So this can do more than what this can give it. So it needs more than 1 watt of input. Alright, I'm just going to have to double check that I can put any more power into this, because I think 1 watt of drive is enough where it might be swinging the gates too hard already. So I'm going to have to figure that one out. Yeah, but anyway, there you go. There's me amplifier test. There you go, 30 dBm, 1 watt of input. Where were we tripping out before, actually? Because that's something I'd like to find out. I think it's like 45%-ish. I think we're tripping out at 6 amps. So 40% drive is half a watt. Okay. Oh no, 28 dBm. We'll be more accurate than that. 28 dBm plus 17 dB of gain. So maybe I'll chuck some maths up on the screen or something and figure out where that was tripping. Oh no, we know the output anyway. And we know the gain, it's 17-ish dB, because you need to see go from, was it -6 up to 10 dBm, so, oh, that's only 14. No, it's not. Hang on. Can't do math, can I? Don't math on stream, and don't math in videos, apparently, either. Alright, catch us all later. That's the end of the amplifier test as it is. So far, this MOSFET lives to see another day. I do have more MOSFETs coming, so probably should test this to destruction, but I think to go any further, I would need to bring my Hermes Lite here and start playing with the real radio. Build up pure signal. It's just going to be a single toroid and, you know, do the stuff. Toroid, step it down, attenuate it, send it out. Then there's got to be a 40-meter filter here. This FET also has to move onto a copper block to prepare for proper in-service use. Alright, catch us all later. Oh, actually no, there's one more video I want to do. I want to have a little screenshot of me moving the power meter of, yeah, Tony's power meter there. Alright, give me a second, I'll get that set up, because I gotta take a video of that too, don't I? Alright, we're on the 200 watt setting here, so 200 watt power. All I have to do is take this to whatever it was, 50-60% I think it was. I think it was 70% that we got to, 65%, something like that. And I'll have the spec in there too. And we'll see this needle swing. Always fun with the old gear, isn't it? Alright, let's see what happens. Hang on. Helps if I keep my finger on the thing. Yeah, 40 watts of output. Okay, alright. 47.3 dBm. No, it's almost 50. Yeah. Actually, according to this, it's actually over 50 watts. But anyway, so 50 watts on the meter there. Alright, have fun. See ya.